Hi, everybody. All right, so I just want to go ahead and get started tonight by reviewing quickly the materials that are on Blackboard for this week, because I know that there's been a little bit of confusion. People have been feeling a little bit overwhelmed by the amount of material that we've been posting. So I just wanted to give you a sense. If you haven't seen it already, if you log into Blackboard, you'll see that the sidebar is now adjusted so that things are hopefully a little bit more clear about where to find things. You have lecture, Monday lab, and Thursday tutorials all here with our various names next to them. Obviously, there are more things here than you'll see when you log in because I'm logged in as the instructor. But you'll see hopefully a reduced and easier to navigate section on the left-hand side of the screen. For our class tutorial today, so if you click on Thursday tutorial, here you'll see the link where you can schedule office hours with me. So these are the Tuesday hours between 6:30 and 8:30. There's a website that you can log on to, and you'll schedule office hours through that website in 15-minute blocks. Um, so you click there, and then if you actually have office hours scheduled, in order to actually come and participate in the office hours, you go under course information here, and you just click on the Blackboard Collaborate online office hours, and you'll be able to log right into the Blackboard Collaborate system, and I'll be there waiting to collaborate with you on those office hours. So for this week, if you scroll down to online tutorial session 4, you'll see that each week I've put a description of what it is that I'm covering that week. And then, so what I've started doing now is putting, I'll always put the link for this tutorial at the very top of the page. I'll always call it tutorial session with a number after it. And you'll always be able to view it either live from 6:30 until whenever it's over, or as a recorded YouTube video. And if you log into YouTube, you'll see that we also have set up some playlists that correspond with each of our various sections of the course. So there's a playlist for the lectures, there's a playlist for the labs, and there's a playlist for these tutorials. Underneath of that, I'll post any exercises that I utilize during the lab session. So prior to the prior to the tutorial session, it'll just be a regular exercise that won't have any answers in it. And then after the tutorial session, I'll typically post a version with answers so that you can see everything that I did, even if it's a little hard to follow live. After that, if there's any other material that I'd like you to review, it'll be below there. What I've started doing is putting extra content in front of things that that I've done myself from previous semesters that you may find helpful. These are from lab sessions that I have run in previous semesters with students in them. So every now and then there will be, moments of time where you won't be able to hear what I'm saying, or there will be a big pause in the time, and that's because I'm probably interacting with students during that time. But anything that it says extra content is something that I've done that I'm posting for you to view if you want to. It's entirely optional. It's if you're struggling and you want to watch it and see if anything makes more sense after watching these things, then please feel free. For example, this is a video recording of last semester's lab session. This is the PowerPoint that I go through during this video. And then this is the Excel document that corresponds with those two, with the PowerPoint and the video. So the extra content is all my stuff. That's totally optional for you to view if you want to. You can totally ignore it if you don't want to. Outside content, again, is a similar thing, but it's stuff that I didn't do. So it's websites that I found or videos that I found that I think could be helpful for you. They're normally pretty brief. The Khan Academy site has a lot of videos and they cover a wide variety of topics. So if you're really struggling to understand a concept, I recommend you go to the Khan Academy. If you're struggling to understand how to execute something in SPSS or Excel, look down below to see if I have posted any YouTube videos on doing things in Excel or SPSS. For this week, I haven't posted any of those. All of the outside content are videos explaining the normal and binomial distributions in case you're struggling to really understand what those are and the difference between them. And then in today's tutorial, what I'll be doing is going through an actual exercise using the Excel binomial distribution functions. Okay, so extra content is my stuff that you don't need to watch, but you can. Outside content is other people's stuff that you don't need to watch, but can. Um, Anything that says either of those things in front of it is totally optional, and you can ignore it if you want to. It's really just the stuff at the very top that doesn't say anything about extra or outside content that you want to pay attention to. None of this stuff is required. You're only required to attend the lecture and the lab. Um, Everything that I cover is stuff that has already been covered in the lecture and the lab. So you're just getting another way of looking at it and another review of it during these tutorials. And so all of this stuff is really optional. But the stuff that you want to pay most attention to is the stuff at the top, because that's the stuff where I'm really trying to take what they did in the lecture in the lab and explain it again to you, maybe in a different way, or maybe, thinking about the assignments in the exam and what you might encounter on that. I might have some examples that are relevant for those things. Okay, so that's just a brief explanation of the way the Blackboard is laid out, because I know that there has been some confusion about what we are looking at on Blackboard. And excuse me one second, I just have a Q&A to answer. You can go ahead and type your question and I'll just answer it out loud. And while I'm doing that, I'll just switch to the other program. So you'll see my screen share go off for a second. Okay. So what we're going to be doing today is looking at an exercise in Excel using the binomial distribution functions. So I know that these can be very confusing. And so what I've tried to do is give you a word problem. And then what we'll be doing throughout a series of steps is really breaking it down, breaking down the information that we get out of the word problem, breaking down the information that we're being asked in the word problem, and then breaking down the steps that we really need in order to answer the question that the word problem is posing. These are all important steps in order of understanding what information you're being given, what information they're asking for, and what you need to do to give that information. And so hopefully by breaking down this one word problem into 10 different steps and questions, I will be helping you guys to figure out the best ways to go about answering one of these word problems that is similar to something you might encounter on the assignments or on the exams. I did see someone had a question that they wanted to ask about the tutorial. I'm not sure if you heard me, but like I said, please just go ahead and type your question and then I'll answer it through the microphone so that everyone can hear my answer. So if you do still have a question, go ahead and pose that question to me. Okay, so the word problem that we're going to be working with says you're playing an online game in which you pay for tokens to play each round. In each round of the game, you have a 75% chance of winning. But if you lose the game, if you lose the round, you must give up one of your tokens. So you pay if you lose, you don't pay if you win. You're willing to spend enough money to buy a total of 20 tokens. So I didn't give you unnecessary information about the amount of money that you have and the amount of money that the tokens cost. You could encounter a word problem where they would give you that information, which would really be for the point of distracting you from the point. And, so you want to make sure that you understand what's being asked of you so that you aren't paying attention to information that's not really necessary. What you really need to know is that you're willing to spend enough money to get a total of 20 tokens. And so I just gave that to you straight in the question, but I could have said something like, you have $10 and tokens cost 50 cents each, and you're willing to spend all of your money, in which case you would need to translate $10 and 50 cents each into being able to spend 20 tokens. For the purpose of this question, I didn't do that, but that is another way that I could have added additional information there to kind of throw you off, is to say something like, you're willing to spend $10 and tokens cost a total of 50 cents each. Okay, so the first thing that we want to do is take the time to figure out what information the question is giving us. And so what we have here are a few pieces of information. So, we're playing an online game. None of that is important to the mathematical problem. In each round of the game, so you're playing a different round each time. In each of those rounds, you have a 75% chance of winning. Okay, so let's put that down first, is that the probability of winning is equal to 0.75. Then we also want to put in the rest of the information. And so, as I said before, I didn't bother giving you information about the amount of money you have and the amount the tokens cost. I just told you exactly what you have. So you just want to put here that the number of tokens that you've been given is 20. And so then that's pretty much all the information that you have. There's no other information that this question is giving you yet. All right, so then we go down to the first question. The first question is, what is the probability of losing in each round? And so we have to think about the information that we've been given and which of that information we can use in order to figure out the probability of losing. So the information that we have so far is the probability of winning and the number of tokens that we have. So if you think about what we need to know, we would need to know the probability of losing. Well, what is the probability of losing? The probability of losing plus the probability of winning equals 1. So the probability of winning and the probability of losing equals 1. Then if we take 1 minus the probability of winning, we would have the probability of losing. So I'm going to put here that I want the probability of losing, and I'm going to put that I want that to be 1 minus, equals 1 minus the probability of winning. And so the probability of losing, in this game is 0.25. All right, so the next question asks, how many rounds can you afford to lose? Now, this is a question that can be a little tricky. How many rounds can you afford to lose? So knowing what we know, how many rounds could we afford to lose? Well, we know that we have 20 tokens and we have to pay 1 token every time we lose a round. So each time we lose a token, and we have a total of 20 tokens. If we take the total number of tokens available, which we lose 1 every time that we lose a round, and divide that by the probability of losing, that will tell us how many times, approximately how many times we can afford to lose based on a probability of losing 25% of the time. So we're going to put here that the number of losses that we can assume that we can afford to make is going to be equal to the number of tokens divided by the probability of losing. And so we have here now that we assume that we can afford to play, or I'm sorry, how many rounds of game, how many can you afford to play? Let me just change this question around a little bit, sorry. So how many can we afford to play? We already know, I'm sorry. I'm moving on to the next question accidentally. This question wasn't actually asking anything confusing. It's just asking how many times we can lose. And we already have that information right here. I've already told you before that every time you lose a token. And so knowing that, we know that we can lose exactly as many times as we have tokens. So this is just going to be equal to the number of tokens that we have. Sorry, I was jumping ahead to the next question already. So this is another pretty straightforward question. The number of losses that we can afford is equal to the number of tokens that we have, because each loss costs us 1 token. Now, say that it was a different scenario. It could be the case that every time we lose, we have to give up 2 of our tokens. In that case, it's not quite so straightforward. If every time we lose, we have to give up 2 tokens, then the number of losses we can afford is the number of tokens divided by 2. So in this case, we'd be able to afford 10 losses. So I've given you a little bit more of a straightforward question. the number of losses is directly proportionate to the number of tokens. But if a loss only costed half a token, or if a loss costed 2 tokens or 5 tokens, then you would need to divide the number of tokens that you have in order to figure out the number of losses that you can afford. So if it costs us 5 tokens every time we lose, then 20 tokens divided by 5 is 4, which means we can only afford 4 losses. In this case, it's 1 and 1, so we can afford 20 losses because we have 20 tokens. Okay, so moving on to the next question. Given the answers to Q1 and Q2, how many total rounds do you expect to be able to play? And what we're asking here is, how many rounds can we win plus how many rounds can we lose? And so I started to answer this accidentally in the previous question. The expected number of rounds that we can play is going to be the number of losses that we can afford divided by the probability of losing. So we can afford to lose 20 times because we have 20 tokens and we pay 1 token every time we lose. If we divide that by the probability of losing, we get an approximation of the number of rounds we can play based on the probability of losing. So all we have to do here is say equals the number of losses that we can afford divided by the probability of losing. So that's why it's helpful to put all of this information step by step so that you have it to easily pull into these formulas as you get to new questions. So as we accidentally figured out in the previous question, and I'm just showing you again now, we can afford approximately to play 80 games. And if you look at this, that makes a lot of sense. The probability of losing is 1 in 4, and we can afford to lose 20 times. So if we can afford to lose 20 times and we're losing approximately 1 in 4 of our games, then 20 times 4 is also 80. So dividing the number of losses by the probability of losing is also similar to figuring out that we are losing 1 in 4 times and multiplying the number of losses by 4. So either of those approaches will give you the same answer, which is that the number of rounds that we can expect to play is about 80. And of course, this is an approximation. And as we'll see as we go further down in these questions, the probability of being able to play 80 is not 100%. We're not 100% sure that we're going to be able to play 80. 80 is, sort of the average number that we expect to be able to play. If we did this over and over again with 20 tokens, 80 is what we would expect to see most often. Okay, the next question is, what is the exact probability of losing 20 times after the expected number of rounds? So we already know here that the expected number of rounds is 80. So we're going to be using that information that we calculated in the previous question and pulling it into the next question. So if you got this question and didn't get question 3, you would need to know to calculate the answer to question 3 before you could calculate this. So if the question doesn't ask you to calculate the number of rounds that you expect to be able to play, you need to figure out that you need to calculate this. And I just want to point out, in this case, the number of rounds is synonymous with the number of trials when we're thinking about the binomial distribution. So rounds of this game are equal to trials in the binomial distribution. So what we want to do here for this question is use the binomial distribution to figure out exactly how many, what the probability is of losing 20 times after the expected number of rounds. Okay, somebody just asked me to explain a little bit more the answer 80 and the expected number of rounds. So I'm just going to quickly go through the 2 ways that you can get to that information. The first way is just a formula. It's a formula that you can use every single time. So the formula that I used is simply the number of losses that we can afford divided by the probability of losing. The number of losses that we can afford divided by the probability that we're going to lose will tell us approximately how many games we expect to be able to play or how many trials in the binomial distribution we expect to be able to do. The other way of doing that is to know that 0.25 is the same as 1 in 4. 0.25 is 25%. 25% is 1 in 4. If you know that it's 1 in 4, a ratio of 1 in 4, then you also know that you can multiply the number of losses by 4 to get the total number of rounds. If I'm losing 25% of the time, you can also work backwards here and guess the number of rounds that you can expect. So if I guess that we could play 60 rounds, if I multiply 60 by the probability of losing 0.25, I get 15 losses. So if I play only 60 rounds, I'm going to lose less often on average than I expect to be able to lose. So you can just keep guessing up. So you could then do equals 75 times the probability of losing. Then I would expect to lose 18.75 times. So then I could go up to 80 and do 80 times 0.25, which is again the probability of losing. Then I would get 20, and that's exactly how many rounds I can afford to lose. And so I know that the number of rounds that I can expect to play is 80. So that's 3 different ways of thinking about how to figure out the expected number of trials or rounds that you can take. Okay, so going back to this, the probability of losing 20 times after 80 rounds. So 20 times is our x when we're thinking about the binomial distribution function in Excel, and 80 rounds is our trials. And so it's really helpful when you're doing these things if you put all of this information in, if you type all of this information out for yourself. You want the probability of what? Losing 20 times after completing 80 rounds. So we're just going to do equals binom.dist, which is our binomial distribution function in Excel. And then it tells us exactly what it wants. It wants number S. So this is the number of losses. So we already put here for ourselves, we're losing 20 times. So we put 20 here, comma, the number of trials, which again, we've already talked about, is 80. So I'm going to pull in the 80 from right here. The probability of losing, which we already have here. So I'm going to pull it in from here, probability of losing. And then whether or not we want it to be cumulative, and yes, we do want it to be cumulative. What cumulative means in this situation is that we want the probability of losing, we want the probability that after 80 rounds, we will have lost anywhere from 0 to 20 times. That's what cumulative means. It means it's going to give us the probability of losing 0 times, plus the probability of losing 1 time, plus the probability of losing 2 times, plus the probability of losing 3 times, all the way up to the probability of losing 20 times, all added together. The probability of each of those individual events occurring is very small, but the probability of losing anywhere from 0 to 20 times will be much larger. And cumulative is going to give us that probability. If we typed false here, then what this function would do is give us the probability of losing exactly 20 times in 80 rounds, which again is going to be a much smaller number, because in some rounds you're going to lose 19, in some rounds you're going to lose 21, in some rounds you might only lose 15, or you might lose 25. So each round, the probability of losing an exact amount is a lot smaller than the probability of losing a range of amounts. And so here, you really need to think about whether you want cumulative or not. And typically, you're going to want a cumulative distribution, not a single non-cumulative distribution. Okay, so the answer to this is 0.56. So what this tells us is that the probability of losing 20 times after 80 rounds, which we've already figured out is what we would expect based on the probability of losing and winning and the number of tokens we have, that probability is actually only about 0.56. Now, like I said, that makes a lot of sense because there are going to be times when we lose more than 20 times after 80 rounds. And so, 20 times is about the average number that we expect to lose. But there are going to be plenty of times when instead we're going to lose 21, 22, 23, 24. So the probability of losing all of those different amounts, now keep in mind that this probability distribution here is the probability of losing 0 to 80 will total 1. So because we have 80 trials, you can lose as few as 0 times and as many as 80 times. And so if you counted the probabilities all the way from 0 to 80, you would get a total of 1, because all probabilities total to 1. And that is the full range of the possible losses. Now, what we're asking for is approximately a quarter of that range. We're asking for the losses from 0 to 20 times, but because of the probability of losing, we're getting this. So the probability that we will lose probability of losing up to 20 times, sorry. Losing up to 20 times after 80 rounds is 0.56. Now, I'm just going to show you quickly. If we had typed false here, just so you can see what typing false does, we get 0.10. 0.10 is the probability of losing exactly 20 times after 80 rounds. So it doesn't include the probability of 19, 18, 17, all the way down to 0. None of those probabilities are included. It's exactly the probability of losing exactly 20 times when you're playing 80 rounds with a probability of losing of 0.25. So if you type false, it's going to give you a much smaller value because it's going to be the probability of losing exactly that number of times. Rather, what we want is the probability of losing up to 20 times. I'm sorry that that question was worded not quite correctly. I'll make sure that the answers version, when I upload it tonight, has the correct wording in it. We want the probability of losing up to 20 times. So we could lose 0, 1, 2, 3, 4, blah, 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 up to 20. That probability is 0.56. The next question we're answering, what is the probability that you could run out of tokens after playing 5 fewer rounds than you expect to play based on Q3? So the first thing we need to do here is figure out what the question is asking. We need to fill in some of the information. What is the probability that you could run out of tokens after playing 5 fewer rounds than you expect to play based on Q3? Well, first of all, how many rounds do we expect to play? And I gave you the place to look for that is Q3, but really what you need to know is to figure out where to look for that information. So what we need to know here is exactly how many rounds we expect to be able to play. That number based off of Q3 is 80. And so what we're going to put here is the probability of losing 20 times after playing 75 rounds. So what is the probability that you could run out of tokens? Translates into what is the probability of losing 20 times, because that's how many tokens we have. So running out of tokens would be losing 20 times after playing 5 fewer rounds than you expect to play based on Q3. So 5 fewer rounds than we expect to play based on Q3, which is 80 rounds, is 75 rounds. So we're looking at the probability of losing 20 times after 75 rounds. So this is going to be equals binom.dist. The number is going to be 20. The trials is going to be 75. The probability still remains 0.25. And now here, because we're asking the exact probability of running out of tokens. So running out of tokens means we lose exactly 20 tokens. If we lose 19 tokens or 18 tokens, we haven't run out of tokens. And so here, like I showed you in the last question, we actually want to do false for this, because what we want is the exact probability of losing 20 times in 75 rounds when the probability of losing is 0.25. So we're actually going to type false for this one. The probability of losing 20 times after 75 rounds is 0.10. So there's about a 10% chance that if we play 75 rounds with these chances of 0.25 for losing, that we will have about a 0.10% probability, or 0.10 probability of losing 20 times. Now, losing up to 20 times would be a much bigger probability. The next question is, what is the probability you could run out of tokens after playing 10 more rounds than you expect to play based on Q3? So this is a very similar question. I'm just giving you another example of the same type of question so you can start to see how I'm getting this information. What we need to know here is the probability that we're going to lose how many times until we run out of tokens. So this is going to be exactly 20 again. And after how many rounds? It's 10 more rounds than we expect to play. And what we expect to play is 80. So it's the probability of losing 20 times after 90 rounds. So this is binom.dist 20, 90. The probability remains 0.25. And again, we want to put false here because what we're asking is the exact probability of losing 20 times, not the probability of losing up to 20 times. So this is going to be false. And that probability is 0.08. So there's a lower probability that we would lose 20 times after 90 rounds than we would lose 20 times after 75 rounds. So we're even less likely to lose 20 times after 90 rounds. Okay, the next question is, what is the minimum number of rounds you could play with a 75% chance that you'll have enough tokens? So this is where the questions start to get a little confusing and where it becomes really important to figure out what the question is asking you. So the first thing you look at is the beginning of the question. It no longer says what is the probability like it did up here. Now the question says, what is the minimum number of rounds? And like I said before, number of rounds in this context is the number of trials. So what we're being asked for, first of all, the most important thing is knowing what type of answer you even need to give. What type of answer we need to give here is going to be framed in terms of trials. It's going to be a number of trials. Okay, so that's the first thing to keep in mind. It's asking us for a number of trials, and it's specifically the number of trials that we could play where the probability is 0.75 that we'll have enough tokens. Again, you have to think about what these words mean because word problems can be tricky. They don't just give you, you have to be able to translate it to these things. Obviously, if we gave you these things, everything would be a lot easier, but you need to be able to translate the word problems into this information. So what we need is the number of trials where the probability of losing exactly 20 times, or sorry, not exactly 20 times, the probability of losing up to 20 times is 0.75. So we want the number of trials where P equals 0.75 for up to 20 losses. Okay, and so that's going to be something that we need to do a little guessing for. So we are going to do equals binom.dist. We want up to 20 losses still. And now here what we have to do is guess the number of trials. So there's no backwards formula that we're going to use here. What we're going to do is just do some guessing. And we're going to guess a few times until we get the right answer. So we're going to do equals binom.dist 20, and then we're going to just guess a number of trials here. So let's guess 100 trials. The probability of losing is still 0.25. What we're looking for is the probability of losing 20 times, not the probability of each loss. So keep in mind, we are looking for a probability, we're looking for a probability like this of 0.75, we're not changing the probability of losing here. So 0.25, and then we do want cumulative again in this situation. So unlike these where we were looking to have exactly 20 losses, where we would totally run out of tokens, so that's exactly 20 losses. Here we're just saying where we would have enough tokens to play. So that means having up to 20 losses. So we're going to do true here and see what it gives us. So it gives us 0. So the probability of losing 20 times after playing 100 rounds with 0.25 probability of losing is 0. I mean, it's not exactly 0, but it rounds to 0 in this case. So now we're going to go down by a little bit. We're going to take 100 down to 90. And we'll see what that gives us in terms of probability. Still 0. All right, let's go down to, we're maybe up too high. Let's do 75. 75 is giving 1. Sorry, it's possible. This may be rounding us. Oh yeah, I'm sorry. This was, oh, sorry, that's because, So this is rounding us a little too much. So the probability here is 0.69 when we do 75 trials. So we actually need a little bit higher probability. And if we need a higher probability, then we're going to decrease the number of trials a little bit more. So we go down from 75 to 70 trials, and we get a p equals 0.80. Now 0.80 is a little too high. So then we're going to go up a little bit. So we're going to go up to 71 and get 0.78. We go up to 72 and we get 0.76. We go up to 73 and we get 0.73. So we're not going to get exactly 0.75 because at 73 we got 0.73 and at 72 we got 0.76. And so we're going to settle for 73. So 73 is going to be our answer for the number of trials where p equals 0.75 for up to 20 losses. And so next to this, I'm just going to put equals, I'm going to put what I had done to calculate this. So binom.dist 20, comma, 73, comma, probability of losing is still 0.25, comma, true. Sorry, not sure why this is not showing up. Oops. So I'll just make sure that the formula that we used is here for you when I upload the answers. So then this is asking a very similar question. What is the number of rounds you can play with a 95% chance that you'll have enough tokens? And again, this should say minimum number of rounds. So we're doing the same kind of thing here. We need to figure out what the question is asking us. So the first thing to notice is the question is asking for the minimum number of rounds. So you know you're not going to be the answer is not a proportion. The answer is going to be number of trials. So it's going to be the number of trials where p equals 0.95 for up to 20 losses. And that up to keys you in that what you're looking for is a cumulative proportion. So you want to say true at the end. So we're just going to do equals binom.dist, and we're just going to try a few numbers. So we know that we need to go lower than 73 in order to get a higher proportion here. So we're going to start maybe at 50. So we're going to do 20 losses out of 50 rounds with our probability of losing still being 0.25 and true for cumulative distribution. And unfortunately, this is rounding too much for us again. And we get 0.99 for that. So what we want is 0.95. And so what we know is that we need to go down a little bit. So we're gonna go down slowly. So we start at 551, still 0.99, 52. Okay, so let's jump to 55 then. So 55 brings us to 0.98. So let's jump to 60 then. And 60 brings us to exactly 0.95. And so then our answer for this question is 60. 60 trials gives us a 95% chance that we'll have enough tokens to play the game with a probability of losing of 0.25 and 20 losses. Okay. What is the probability that you could play the game 85 times and still have 5 tokens left? So the first thing to know, this question is again asking for a probability. So this is the probability. This is the probability of losing. Sorry, my Excel is being a little weird here. This is the probability of losing. And how many times are we losing? So we could play the game 85 times. Well, that's the number of trials, so that's not what we need yet. And still have 5 tokens left. Well, there it is. That's the information we need. So we know that we have 20 tokens total. If we want to play and still have 5 tokens left, then we need to figure out how many times we're trying to lose in this situation. So in this case, if we want us to have 5 tokens left, that means that we're losing 15 times. The number of tokens we have is 20. We want to still have 5 left. So we're losing 15 times in this scenario after 85 rounds. Okay, and so we just do equals binomial dot distribution, and this time our number of losses is only 15. Then the number of trials is 85. The probability of losing is still the same in this scenario, still 0.25. And then do we want to do a cumulative distribution or not? Well, we still want to have 5 tokens left. So that means we could have 6 tokens left and only lose 14 times. Or I'm sorry, well, this question is, again, sorry, not worded completely clearly. Still have at least 5 tokens left is what I wanted to say here. So we still want to have at least 5 tokens left at the end. So we want the binomial distribution of losing 15 times in 85 rounds with a 0.25 probability of losing. And we do want a cumulative distribution here because keep in mind, having at least 5 tokens left means we could also have 6 tokens left or 7 tokens left or 8 tokens left, which means we could lose only once or twice or 12 or 13 or 14 times. All of those things are fine. What we want to have is at least 5 tokens left at the end of this round. So we want the probability of losing anywhere from 0 to 15 times out of 85 rounds. That probability is 0.07. So not very good. We don't stand a very good chance of playing 85 times and leaving the game with at least 5 tokens left. Then the last question is going to be the same type of thing, but again, I'm rephrasing it just so that you can get more practice with extracting the information that you need out of these questions. This question is, what is the probability that you could play the game 90 times, and still have at least 10 tokens left? So we're playing. So you have to remember how to get this probability of losing, or I'm sorry, not the probability of losing, the number of losses. So the probability of losing, and how many times are we losing now? If we want at least 10 tokens left, then we're losing up to 10 times. So probability of losing 10 times, and this time we're playing 90 rounds. So as you can probably guess, this probability is going to be incredibly small. The probability that we're only going to lose 10 times after 90 rounds with a 0.25 probability of losing in every round is going to be incredibly small. You know, if you can, try to think about these things conceptually as well. You know, first of all, the probability of losing 20 times after 75 rounds, well, this is exactly 20 times, so let's not compare it to that. But the probability of losing 20 times after 80 rounds with a cumulative probability here was only 0.56. So 20 out of 80 was 0.56. 10 out of 90 is obviously going to be much lower than that because the probability of losing is 0.25. So we're expecting to lose 1 in 4 rounds. 10 out of 9 is much greater than 1 out of 4. 10 out of 90 is the same as 1 out of 9. 1 out of 9 is much fewer than 1 out of 4. So we're going to do here binom.dist 10, 90. The probability of losing remains 0.25. That has not changed at all throughout the questions. And then we want true because, again, we can lose up to 10 rounds and still have at least 10 tokens left. If we have 11 tokens left or 12 tokens left, great, which means we've only lost 8 or 9 times. That's totally fine. So we want to include those probabilities here. And like we suspected, that is a very small probability. So it's giving us 0, but that's rounded. So if we take this out a little bit, the probability is 0.0008. So an incredibly, incredibly small probability that we will play this game with a 0.25 probability of losing each round, and we'll come out with only losing 10 times out of 90. Now, it's not impossible. Every now and then you will get a binomial trial where this actually is the case, and it does occur, hence why it's not completely 0, but this is going to be incredibly rare. every 10,000 games you play, this is going to happen approximately 8 times. So, not a very common situation. Okay, so that is all I wanted to go through with you today. If it hasn't sunk in yet, I hope that you'll go back and try doing them yourselves for a little bit. And then if that doesn't work, go back and watch the video again. Try to see where you got stuck and what I might have said that would help you. If you have questions still after doing that, please feel free to email me. I think that a lot of these are going to be helpful in thinking about the assignment. So, I'm willing to answer questions about this, although obviously I can't give you any answers for the assignment. So I hope that this has been helpful. That is it for this evening. And I will talk to you guys next week.